Last time we talked about draw our testing environment for our final presentation. And today we are going to introduce how this is done in Duckietown. Okay, and we will talk about the pause and transformation. And we will also talk about some of the formats to draw a cute ducky bot in RVs. Okay, and as well as the map, the environment for sure. Okay, and we will also introduce some of the package like a TF. Essentially, it's a transformation package. You have seen the Duckietown description, so that's also a package already in the repo that can draw this map. This will be the first part of the lecture, and the second part, Brian will give us another tutorial about those transformations, how to use row, pitch, and yaw, and also, for example, use quaternion or matrix, how to do the computation, how to do the composition of multiple transformations. Okay, and second part, you already see some of the setup over here. So we have a mocap tutorial by Jack. We would like to keep our show time. It's more like last time we have a land following contest, and some of the team were pretty impressive. And I hope you guys can do this again with the snacks and drinks. Okay. Okay, and last time when we talked about the problem formulation, one of the tasks is to draw your Duckietown environment to prove your concept of your final project. And I would like to just refresh your memory a little bit, and hopefully we can use the components in Duckietown description and draw your own environment. Okay, so yeah, I just show you guys those very quickly. Left should be the little car, right? Try to do the taking over. And the right one, this is pretty similar to what we have now. This should be Sakuban, right? So this is probably a little bit a more complex environment. And maybe you can find a simple way to draw it by the Duckietown description. We actually have some of the essential components. You can draw the environment pretty easily. That one, probably little car, the other team again, right? Try to, probably the duck roach will show up from the left-hand side and go to the right-hand side. Just make the problem a little bit simpler. Some other interesting environment, I think we can draw off them somehow. And actually, if you can see this environment here, it's a 5x5. This looks like some kind of patrol robot. And the parking, right? This seems like a person following the other project. Okay. And also the delivering and parking, right? This should be top bot, right? Yeah. Okay, so we have seen some of the design. The first thing is how to represent a pause in 3D. So since we are going to draw something, we are going to draw the map, draw the environment in RVs. We definitely want to give the ducky bot a right orientation and position so that you can see a ducky bot moving in the environment. Okay, so essentially in 3D, it's very straightforward. We will have the position, X, Y, and Z, and we have the orientation. And for 3D orientation, there are a few ways to represent an orientation. The first one is called row, pitch, and yaw. So if you can borrow me your right hand, just like this, okay. So you can see the ducky bot over there. So the forward is the X direction, and the y direction is the side weight, and this is a z. Okay. And for orientation, the easiest way would be roll, pitch, and yaw. So the roll is more like this, something like you roll over somehow, right? A robot rolling. Okay. And this is pitch. Okay. And this is yaw. Okay. So if we simplify the problem to 2D, then in our position, we will only have x and y, right? We won't be able to see the vertical, the z direction. In 2D pulse, you will think that you will see it like this. So the only thing you can see is the yaw, all right? Okay, there are some other representations to show the same RPY, for example, the quaternion. Okay, and you can also use a rotation matrix. It's a 3x3 matrix, then it will show exactly the same thing. And I personally like the rotation matrix a lot because it will give us some very easy to understand matrix multiplication. Now we know about what's the pulse in 3D and 2D, and let's talk about some transformation. So essentially, a transformation includes both translation and rotation. Okay, the translation is actually the difference between two pulses in x and y and z. Okay, and the rotation, we just talked about that. You can think that suppose we are at this position and the pulse, 3D pulse is like this. And when we make a turn, it will become the other robot over here. So actually, you can compute the translation just by its x, y, and z. Okay, and the rotation, you can also compute the rotation as well. Okay, yeah. So this is probably the easiest way to compute the rotation. And rotation matrix is a 3x3 matrix. And one thing to notice that it's an invertible matrix. So you can see that for roll, pitch, and yaw, and if we have the angle over there, and we can formulate a 3x3 matrix in each direction. Okay. And for a transformation matrix, you can see that this is the R. This is just the rotation 3x3 matrix. And the Tx, Ty, and Tz, they are the translation. Okay. And the good thing is that you can do the composition of multiple transformation. Okay. So for example, you start from here, and you do the transformation 2 times, and you can just multiply them. So now we know what's a pulse. In 3D, 2D, we know what's a rotation matrix. We know a transformation matrix. And now let's take a look at how to use them in Duckietown. First thing we would like to introduce is it's called URDF, Unified Robot Description Format. And it's an XML format. You can see it over there. And you can see some of the attributes and values in this XML. And for example, one interesting thing is here, the mesh. So the mesh duckybot.dae. The DAE actually show you a nice 3D duckybot in RVs. And it also show the RPY. So it's a roll, pitch, and yaw, and the X, Y, and Z. You can define where and what rotation of your robot. Okay, and the next thing we would like to introduce is called XACRO or XACRO, an XML format file. And the good things about XACRO is that it's more like a macro, and it can generate the URDF in a nice way. Okay. But later on, because XACRO itself is also a little bit complicated, the Duckietown people, they try to simplify this process by just creating a CSV, a comma separate value. It's another file. For example, if you look into the Duckietown Description, tiles 4e.csv, and you can see a few definitions over here. And they are essentially the definition for building a map for you. Okay? And we can also put a couple April tag in the environment. So in this example, we put 2 of them. The process is like this. You define the tiles, define the text, and the parser is provided by the Duckietown report. And you will get this XACRO file. And the XACRO file, it will be automatically converted to URDF in Rust launch. This is the code to convert CSV to urdf.xacro. Okay, and you can try it. But before that, let's take a look at an example together. The output name is called map 4e2. This is a definition for the URDF generated by the 2 CSV files. Okay, and you can see we have 2 texts over there, and we also can see a few tiles. Okay. And you may be curious that where did I get the DAE file? So how many of you have played with some like 3D models? There are also some files in SketchUp. Yeah, so it's also already in the Duckietown repo. Yeah, so you can actually generate some of the different 3D objects or textures in the SketchUp and put it into the RVs. So this is the example for creating your own DAE file. Okay, so we will try to practice the converting from CSV to XACRO and then to URDF later. So let's quickly look through the TF package. Okay, and the TF is essentially it will that the user keep track of multiple coordinate frames over time. Essentially, it's a tree structure. You guys know R2D2, right? It's in Star Wars, R2D2. Okay, something like a trash can. Because the ducky bar itself, there is no arm on the robot, so it only have its own frame. Okay, but for R2D2, it's a little bit different. The R2D2 itself, there could be a frame called base link for its own pause. And when his arm pull out, and there will be some other frames coming up. Okay, for example, the arms or the grippers. Okay, so there will be some other frames, and it could be organized in the TF or in a tree structure. Okay, and actually, in addition to the robot, the map itself could be also organized in a tree structure. If you open the TF option, okay, you will see that each tiles they are kind of the children of the world frame. Okay, and the tag is on some of the tiles, so it's more like a structure. So the world, a few tiles, and some of the tile will have some text on it. Okay, so there will be more like a relative position and pause.